Unit cell and crystal lattice. Types of unit cell in crystal systems. Based upon the axial angle and the edge length, the crystals are classified into 7 types. The 7 crystal systems give rise to 14 possible 3-dimensional lattices. These are called as Brevis lattices. Let us consider one by one the crystal system, possible variation, axial distance or edge length, axial angle, and example. First one is cubic crystal system. Here the possible variation it can have is primitive, that means simple unit cell, BCC body centered unit cell, FCC face centered unit cell. Axial distance, here A is equals to B is equals to C, all sides are equal. Axial angle, alpha is equals to beta is equals to gamma is equals to 90 degree. Here all the angles are equal to 90 degree. Example is NaCl, copper, zinc blend. These are the example for cubic unit cell. Second type of crystal system is tetragonal. The possible variation it can have is primitive and BCC. Axial distance, A is equals to B but B is not equals to C. Axial angles, alpha is equals to beta is equals to gamma is equals to 90 degree. All the angles are equal. Examples are white tin, SnO2 and calcium sulfate. Third type is orthorhombic. Here the possible variations are primitive, BCC, FCC and end face centered. The axial distance are A is not equals to B is not equals to C. All the sides are unequal here. The axial angle is alpha is equals to beta is equals to gamma is equals to 90 degree. All the angles are equal. Examples are rhombic sulfur and KNO3. These are the example for orthorhombic crystal system. Fourth type of crystal system, hexagonal. The possible variations are primitive. The axial distance is A is equals to B but B is not equals to C. The axial angles alpha is equals to beta is equals to 90 degree and gamma is equals to 120 degree. Examples are graphite, zinc oxide and CDS. These are the example for hexagonal crystal system. Fifth one, rhombohedral or trigonal. Possible variations are primitive. Axial distances are A is equals to B, B is equals to C. Axial angle, alpha is equals to beta is equals to gamma which is not equals to 90 degree. The examples are calcite. Sixth type of crystal system, monoclinic. Possible variation, primitive and end face centered. Axial distance, A is not equals to B, B is not equals to C. Axial angle, alpha is equals to gamma is equals to 90 degree, beta is not equals to 90 degree. Examples, monoclinic sulfur and sodium sulfate decahydrate. Seventh one, triclinic system. Possible variation, primitive. Axial distance, A is not equals to B is not equals to C. Axial angle, alpha is not equals to beta is not equals to gamma and it is not equals to 90 degree. Examples, potassium dichromate, copper sulfate dot 5H2O. If you observe this triclinic system, it is the most unsymmetrical system in the 7 crystal systems because in triclinic system all the angles are unequal and which is not equals to 90 and the all the edge lengths are not equals. So it is a most unsymmetrical crystal system. One more thing, if you observe all type of possible variations, if you add all type of possible variation, you will be getting total 14 types of variation and that we call it as Brevis lattices. By observing all the type of crystal system, most symmetrical crystal system is cubic because it has all the sides equal and all the angles are also equal. Second one, most unsymmetrical crystal system is triclinic because all the angles are not equal and it is not equals to 90 degree and all the sides are also not equal. Last one, The crystal system with all type of variation is orthorhombic. Orthorhombic is having all kinds of variation like primitive and face centered, body centered and end face centered. Calculation of number of atoms in cubic unit cell. In order to calculate the number of atoms in the unit cell, we should know the contribution of each atom towards that unit cell. First, I will take the atoms are at the corners. If the atoms are at the corners, then that atom is equally shared by other 8 unit cells. Hence, its contribution is only 1 by 8 towards that particular unit cell. Second position is face centered position. If the atom is at the face center, it will be shared by 2 other unit cells. Hence, it contributes only 1 by 2. Other possibility is the atom is at the edge center. If the atom is at the edge center, it is equally shared by other 4 unit cells. So its contribution is only 1 by 4. Last possibility is the body centered atom. It belongs to only one unit cell, hence it contributes one full atom towards one unit cell. Here is the position of the atom, number of unit cell with which it is shared, and the contribution towards one unit cell. First, corner atom. It is shared with the other 8 unit cell, hence its contribution is 1 by 8. Second one is face center. It is shared with equally other 2 unit cell, hence its contribution is 1 by 2. Edge center atom. It is equally shared with other 4 unit cell, hence its contribution is 1 by 4. Body centered atom. It is shared with only one atom, hence its contribution is 1. First one, calculation of number of atoms in simple cubic unit cell. It is abbreviated as SCC, or it is also called as primitive unit cell. If you observe the simple cubic unit cell, in simple cubic unit cell there are 8 corner atoms. You can look at here. So these are the 2, 3, 4, 5, 6, 7, 8. There are 8 corner atoms. Total lattice points are 8, and now we'll calculate how many atoms are present in a simple cubic unit cell. We have 8 corner atoms and its contribution is only 1 by 8 towards one unit cell. Hence 8 into 1 by 8 is equals to 1. Therefore, the number of atoms in SCC is equals to 1. If they have asked how many lattice points are present, then the answer is 8. But if they have asked how many atoms are present in the simple cubic unit cell, then the answer is 1. Second one is body centered unit cell. It is abbreviated as BCC. If you observe the body centered unit cell, how many lattice points are present? Look at here. There are 8 corner atoms: 1, 2, 3, 4, 5, 6, 7, 8 corner atoms, and this is the one body centered atom. So that means total 9 lattice points are present in body centered unit cell. But we want to calculate how many atoms are present in BCC unit cell. Number of atoms are denoted as Z is equals to 8 atoms which are at the corner, which is common for all kinds of unit cell, and the contribution is 1 by 8, plus we have one atom at the body center and its contribution is 1 towards that unit cell. Hence the number of atoms in BCC unit cell is equals to 8 into 1 by 8 plus 1, that is equals to 2. Therefore there are 2 atoms in the body centered unit cell and the lattice points are 9. Next one is face centered unit cell, abbreviated as FCC. If you observe the FCC unit cell, there are 8 atoms are at the corners. You can look at here. These are the 8 corner atoms: 1, 2, 3, 4, 5, 6, 7, 8. In addition to this one, we have 6 face centered atoms. Look at here. This is the 1, 2, 3, 4, 5, 6. These are the face centered atoms. 8 corner atoms and 6 face centered atoms. So total lattice points are 14. Now we have to calculate the number of atoms in FCC. Z is equals to 8 atoms are at the corner and its contribution is 1 by 8, plus we have 6 atoms are at the face center and its contribution is 1 by 2. Hence, total number of atoms in FCC is equals to 8 into 1 by 8 plus 6 into 1 by 2 is equals to 4. Therefore, number of atoms in FCC is equals to 4 and the lattice points in FCC is equals to 14.